Hey there, everyone, and welcome to Weather Classroom. I'm Thomas Patrick, meteorologist with Crem 2 News in Spokane, Washington. Great to be back here on YouTube. Happy fall, by the way, everyone. The colder weather has finally returned. We actually just got a cold front that moved through this morning in the area, expecting our first freeze of the season later this week. And by the way, the fall colors, the foliage is looking spectacular, and expecting that to peak next week in the area. So there is some great fall colors, not just here in Washington, all across the country from what I've been seeing on Twitter as well. But I'm already looking a season ahead towards the winter outlook, believe it or not. And that actually leads us to our topic of the day, La Niña or El Nino. Actually, they're one and the same. They're actually two sides of the same coin. So El Nino and La Niña, or the El Nino Southern Oscillation, as it is aptly named, is a weather pattern in the Pacific Ocean that influences the winter weather pattern across North America. But before we get into those patterns, let's just tell you, what is it, and define what is El Nino and La Niña. And it has to do with water temperatures in the Pacific Ocean around the equator. In fact, on this graphic that you see here, the boxed area is what we call El Nino 3.4, or at least that's the sector name. There's a few different sectors that define where El Nino is, but this is the most important one and the most simple one that we can define. So we usually look at the water temperatures and see, quite simply, if they're above normal or below normal. And if they're above normal, they're El Nino, and if they're below normal, they're La Niña. And in this case, they're currently below normal by about an average of 0.2 of a degree Celsius, which is not much, but it is enough. There's plenty of heat content that a little change in water temperatures actually does make a big difference in terms of global weather patterns, especially on a hemispheric scale. The forecast is for this to actually strengthen into the wintertime to about 0.6 or 0.7 degrees Celsius below normal, which would be considered a weak La Nina. A moderate one would be 1 degree Celsius, and a strong one would be 1.5 degrees Celsius, and vice versa for El Nino as well. So that's the sector of the Earth that we watch for those water temperatures to be above or below normal. And from there, that affects a number of things. One, it affects the global temperatures by, again, a couple tenths of a degree in either direction. It affects the trade winds and how strong they are. In La Nina's case, it actually increases the strength of the trade winds. And then it adjusts the high pressure and low pressure areas across the hemispheres and the jet streams as well. And it's those jet streams across North America that make the big difference in terms of how the winter weather pattern usually lays out for us. On the left, you see the El Nino pattern. You get a extended subtropical jet stream across the Pacific Ocean, and that usually gives the southern U.S. the colder and wetter weather pattern, where it tends to be a bit warmer and drier in the northern hemisphere. And then those roles are reversed for La Nina, the colder and wetter patterns for the northern U.S., wetter especially for the Pacific Northwest and portions of the Midwest, and then drier and warmer for most of the southern U.S. So that is, again, typically how it lays out. Let's take another in-depth look at La Nina here. We end up getting the semi-permanent high-pressure area over the northern Pacific Ocean. So that's why the jet stream arches in a ridge shape over the Pacific Ocean, but it draws from a lot of that cold Pacific water. We get these Arctic air intrusions quite often across the Pacific Northwest, the northern plains, and into the Midwestern U.S. So those colder spells are very much the norm during a La Nina weather pattern, with some variability with general weather patterns. The pattern that you see here doesn't look like this all 90 days during a La Nina winter. The jet stream will still move, and it will still be variable, and we'll get these pieces of energy in low pressure areas that ride it to give us those snowstorms and wet weather patterns. And things can change from a day-to-day basis, but this is more like a home base, if you will. And should the jet stream set up like this, we get these exact weather patterns, but there is a bit of variability here and there. So I did a lot of data digging for my home base in Spokane, Washington, which is, of course, on the other side of the state from Seattle. So whereas Seattle rarely sees any snow, even on a cold winter, here we actually get plenty of snow. We usually average about 45 inches of snow every winter, and there is no case where we get no snow. That much is for sure. So here are the last 10 La Nina winters going back the last 21 years. So we've actually seen La Nina in various strengths quite often recently. And you can see temperature wise, it's been ranging between about 24 degrees on average to as warm as actually last year's La Nina, 31 and a half. But the snow can be quite variable, but more often than not, we end up above average in terms of snow, including last year. I probably would analyze last year as more of like an average snowfall. It was a little bit above average. It was actually kind of strange where it was very front loaded as opposed to no snow in like March and April. But what really stands out in Spokane, Washington is that two of the top three snowiest winters of all time were La Nina winters. And they were actually quite strong La Nina patterns as well. 2007, 2008, and then 2008, 2009. That's right. Back to back winters saw 90 plus inches of snowfall, including that record setter of 97.7 inches of snow, 2008 and 2009. So obviously, there's a very high end potential. Getting 60 inches of snow or thereabouts is actually quite normal in terms of La Nina standards, but it doesn't happen all the time. You can see grayed out that 2005 2006 winter, a La Nina winter, didn't really pan out. That was kind of a bust. So it's not a guarantee, it's usually just typical. And today I sat down with our friends at the National Weather Service because they love data digging as much as I do, and they've been here for all the La Nina winters, the extremes, and the busts all the same, and they've offered some great insight as to what we can expect in the inland Northwest. Hey there, today I'm joined by Andy Brown of the National Weather Service right here in Spokane, Washington. Andy, how are you doing today? Thanks again for joining me again.
No problem. Love to do it. It's great to see you.
Yeah, great to see you. And I know we just had that cold front move through this morning. So, as the old Game of Thrones cliche goes, winter is coming. And, everybody's been asking us about, the winter outlook. And sometimes in the summertime, it's just like, it's still summer. We still got the warmest days. We'll get to the winter outlook when we get there. But now I think we finally turned the corner and we're starting to get shades of the La Nina forecast once again for this winter. And I think the basics are well out there. I think most people now understand that El Nino and La Nina refers to the ocean temperatures being above and below average and respectively. And for us, Pacific Northwest, tend to get that colder, wetter, sometimes snowier than average winters. But there's a lot of steps that go in between getting from ocean water temperatures to colder for the Pacific Northwest. So, what are the steps and the dominoes that have to fall to
Oh boy.
make that pattern viable for us?
Yeah, it's amazing to me how the ocean water temperatures, whether they're above or below normal, can impact such a large area. It's on the hemispheric scale that we're looking at. And so it all depends. It really does affect where the jet stream typically will set up, whether it's below average normal or above average. So, like you said, in La Nina, we see this certain pattern will set up, and it's very common. It happens during these La Nina winters where the jet stream will be in a certain way. It'll set up just right, and so it typically means for us more active weather and colder air intrusion. So we'll have more Arctic air intrusions, and then we'll get that moisture on top of it. And you add those two things together, and it's that four-letter S word, snow.
Yes, and I know that you and I were just talking about the chances for such in the weeks ahead, but I digress. But you used a key word, and that's the typically. Likely,
Yes.
it's not a guarantee because there are steps that go in between the observation of colder than average sea surface temperature waters in the equatorial Pacific Ocean, but it doesn't always pan out that way, but more often than not. So how likely, if you could put a percentage to it, when we get a La Nina winter, how likely is it that we get colder, wetter, snowier than average conditions?
So I was looking at some statistics, and that's one of the fun things I like to do is
Same.
exactly like you're saying.
Yeah.
It's how likely. What do the statistics say? On average, our La Nina winters in Spokane, we have 123% of our average snowfall. So if our average snowfall is like 48 to 50 inches, we'll be 123% of that. So we're talking about 60
Yeah.
inches or so during a La Nina winter. Not every winter is exactly 60 inches. Of course, there's some variation. There could be 40 something, there might be 80 something. We have all that variability, but if you average it all together, it's 123% of normal. If I had to put a number on it, I would say more than likely.
Yeah,
Maybe 60% chance. It's better than a flip of the coin, but it's like you said, it's not a guarantee.
yeah, I was actually gonna say closer to maybe 70% because I remember looking through those yearly datas and I made like this spreadsheet. I didn't do it
Right,
percentage wise. I think it ended up being like 7 or 8 inches of snow more than the 30-year average, and
right.
yeah, that sounds to be about in the wheelhouse there, maybe like 10 or more inches, but.
Yep.
Yeah, a lot of variability still, and I think last year was a good case example of it. It was kind of
Yeah.
odd because it ended up being a little warmer than average, but we still got our snowfall. But our snowfall fell at different parts of the year than what were normal. In fact, one of the biggest things when I was looking back and seeing comments, especially on our social media platforms, so
Mhm.
one person
Yeah.
was like, I bought a brand new snowblower and I didn't get to use it all winter. And it's just like, well, when did you buy the snowblower? Because if you bought it in the middle of winter, then yeah, you probably didn't get to use it all that often because we got basically
Right.
no snow in March and April. But we had such a
Yeah.
front loaded year with the October, November, December snowfall. So it is kind of odd that it doesn't, it's not always colder and snowier. In that case, it was a
Right.
little bit warmer, but still kind of snowy.
Yeah, we were in an active pattern early in the winter, and so I recall that we had like 7 inches in late October, and then we had another large event at the end of December, right before the 1st of January, where we had another 6 to 8 inches somewhere in that area in the Spokane area. So we that's the part that I like to message and continue to remind folks is we're gonna get snow. It
Yeah.
might not all come at the same time, but we're going to have those periods, that fluctuation, where we're going to see some seasonal variability, but we're going to have snow. Whether it's, it stacks up to be that 60 inch or more, at some point, we're going to have to deal with winter driving conditions and shoveling the snow and all those fun things that we have to deal
You know
with.
what that reminds me of? It reminds me of like the old Farmer's Almanac or those winter
Oh,
projections where it's just like Pacific Northwest, cold and snowy. It's like, oh, so we're gonna
yeah,
have winter this winter, right?
exactly.
Like that's not going to change. Whether it's La
Right.
Nina, El Nino, we're still gonna get snow.
We're still going to get snow. At some point this winter, everybody that lives in Spokane is going to have to wake up and deal with that commute, that rough commute, either going home or going to work or wherever they're going. It's going to happen.
Yeah,
So that's my always my main message is just be ready, just be
yeah.
prepared for those days.
All right, and let's talk about some of the extremes because while last year was
Sure.
kind of a weird case example of it being a little bit warmer than average, the winters that really stand out in Spokane are the 2007, 2008, and then
Yep.
2008, 2009, which were back-to-back La
Yep.
Nina winters.
Back.
Both had
That's right.
90 plus inches of snowfall, and I
That's right.
believe if my statistics are correct, the 809 was 97 and change most ever
Sounds about
snowfall.
right. Yep. Yep. That sounds right.
Yeah.
And what's interesting is we've been looking at that. How many times have there been back-to-back La Nina winters? And I think what the numbers say is 7 times that we've had back-to-back La Nina winters. Not every one of them. So what happens in the second winter of those back-to-back winters? And not every one of them was like the 0809 where we had 97 inches. Sometimes we had 40 inches. There's that variability. Odds are, yes, that we'll have a snowier than average winter, but there's going to be some variability too.
Yeah, everybody always remembers those years, and some people wish
Always.
that they love snow. I mean, we got plenty of
Right.
skiers that they're like, "Bring on the snow! We
Bring
want
it.
08, 09 again," and hopefully, our cities are prepared for those kind of winters all over again. Not that we may or may not get it. But those winters were kind of interesting because looking back, we can detail La Nina as being weak, moderate, or strong, and I believe those were strong and moderate respectively. Where actually that second year, the 0809, wasn't quite as strong as that first year. That was the big La Nina, and of course we did get a ton of snow. But that correlation to weak to strong doesn't always correlate to a little bit more snow and a lot more snow. Not exactly.
Exactly. And especially here in Spokane, at this latitude and our elevation, sometimes just a few 100 feet of elevation can make a huge difference in whether we get rain or snow. So when you look at the end of the year numbers and you think, well, we had 50 inches of snow, whatever it is, If we were just 2 degrees colder on a couple of other events, we might have had 60 or 70 inches.
Yeah.
That temperature, it can be so close, and it plays a huge role in how much snow we get in the lower elevations. And again, mountains especially are more likely to get this heavy snow. That's what happened this past year. The Cascades had tons of snow.
Yeah.
They were doing really, really well all the way through March when the faucet turned off
Yeah.
this past year. But the mountains are more likely to get that heavy snow for those skiers that really like that. I and again, I'm not a betting man, but if I was a skier and a betting man, I would put my money on it being a good season.
Yeah. I only do like media day skiing, so it's just always like once or
Right.
twice a year. But it's always like great fun, and I know our skiers
It
certainly
is.
love and appreciate that snow. I think there was an article last year about like the Cascades having like a 10-year high in terms of that snowpack. So
Yeah.
they certainly got the snow, even if that elevation makes a big difference. And we know it does. How many times does it snow? At your office near Aorai Heights or here at our studios on the South Hill, but it's not snowing downtown, which is like 500 feet elevation
Exactly.
lower. Big difference.
Exactly. It makes a big difference, especially in the shoulder seasons and fall and spring. Just a few degrees and a few 100 feet, sometimes it's a 50 feet elevation can make a big difference. So that's part of the challenge of the forecasters, really dialing into where that temperature exactly is going to be, so we can forecast rain or snow or a mix or whatever it's going to be.
All right, I got one more question for you, and
Sure.
I don't know if you know the answer to this or not, but it's something that is something that sparked my curiosity.
Okay.
With the climate change impact on top of El Nino and La Nina. La Nina in particular, because with a warming climate, now our global average temperatures are getting a little bit warmer. Water temperatures are also generally getting a little bit warmer. But La Nina is a colder than average observation in terms of those
Right.
ocean temperatures. So when you match the two together,
Right.
do you end up with something that might be a bit more on the neutral side of things
Right.
with La Nina? Does it still affect our jet stream patterns the same way, regardless of climate change? There's a lot of unknowns here, and I'm sure there's a lot of
Right.
studies that are being done. But I just wanted to get your perspective on how climate change and La Nina kind of line up and stack together.
Right. That is a great question, and I've read some about that. You're right. There's a lot of studies that are happening about that. Is how is climate change affecting La Nina, and what used to be a neutral or an El Nino temperature, which is plus or minus zero point 0.5 degrees Celsius.
Hmm.
How does that change with a changing climate? And what I understand is they are also making that adjustment. So as the global temperatures come up, they're making that adjustment for the ocean temperatures as well. So we're still seeing the same effect. It's not like we're comparing apples and oranges. We're not comparing the sea surface temperatures from the 1950s to 2020. We're actually comparing what is normal in the last 20 years to what is the sea surface temperatures here that we're experiencing. So they are making those adjustments. And so far, we're still seeing those same variations that we still should expect that jet stream pattern for a La Nina to develop, or an El Nino winter where it's not going to, and it's going to mainly affect the southern U.S. So far, as they have done all these studies and they're making these adjustments, we're still seeing that play out as it should, as we expect it to.
Yeah, and that makes sense because we update our 30-year averages every
Right.
decade. So you would think
Yep.
that the same thing is being applied to not
Exactly.
just an individual city like Spokane, but just, what is the average water
Yeah.
temperatures? And now that average has changed, and now we can still analyze and observe if it's El Nino or La Nina.
Exactly. Yep. That
Awesome.
is a great question. That's a great point, because
Hmm.
that has been a hot topic, and I've seen a lot of research on that as well. So that is a great question.
Yeah, I know. I don't think I'm a betting man either. So I'll spare you the how much snow are we going to get this season. Let's just
Thank you.
say it'll snow, right?
It's going to snow. That's right. Just be ready for snow. It's the Pacific Northwest, so just be ready.
Well, Andy, thank you so much again for joining me today. I know it's a
Mhm.
season's getting a little bit colder. The fall colors are really coming alive in the area. We're all looking
Yep.
forward to winter, at least in one way or another. Isn't that right?
Exactly. I'm looking forward to it. I'm a big winter man. I lived in Alaska for a long time, so I love the snow. Bring it on.
Yeah.
I live on that side of the house.
Awesome. Well, thank you so much, Andy, and take care.
You're welcome. All right, thanks.
Andy is fantastic, and we could have probably gone on for another 15 minutes there. But just to recap once again, the El Nino / La Nina weather pattern, what it is at its base is the difference of Pacific Ocean water temperatures versus normal. And whether it's above normal, that's what makes El Nino. Below normal makes La Nina. This affects directly the global temperatures, at least on a small scale, and by extension, the jet streams and the wind patterns across the Earth and across the hemisphere. So that's why when those jet streams are moved or altered or just positioned in a slightly way because of El Nino and La Nina, that's how we get our weather patterns in the winter time, which is where they affect the seasons the most. And in the Pacific Northwest, those winters end up being colder, wetter, and snowier than average, even if it is just by a margin. As Andy said, 123% of our average snowfall when we get La Nina winters. So in that kind of like 7 or 10 inches more than what is normal. It's not a perfect correlation, but it is generally how we do see those weather patterns. And to just show you those maps again and to see on the right side of your screen that La Nina pattern, that's basically how it sets up. And if you think of it from a big scale, if you even looked at last year's La Nina and the above average temperatures, below average temperatures, wetter, drier than average for the season, you'll see that it generally looked exactly like what La Nina is supposed to look like, if not just shifted ever so slightly. I think one of the biggest changes between last year's La Nina and what this normal La Nina winter pattern is that this wetter than average area over the Midwest was actually a little bit farther to the west. It was over like Nebraska, South Dakota, Iowa. It was more in that area than it was, say, centered over Ohio. But that drier pattern across the southern U.S., that was pretty much just perfect in terms of what a La Nina should be. So even if it didn't snow quite as much as it was supposed to in Spokane, Washington, well, Seattle had very much a wetter than average, as expected, La Nina winter come last year. So we are generally expecting that same kind of pattern once again for this winter, albeit it is going to be a weak La Nina pattern. So there's a bit more variability that could be introduced, but we will of course see where the winter guides us. Be sure to follow myself and Krem2 News right here on YouTube. Hit that subscribe button so you don't miss out on a single weather classroom. You can find me anywhere on social media at Thomas Patrick WX. You can share your fall pictures with me as well. I am loving to see the fall colors really start to come alive as they are this week and again for next week. So be sure to share those pictures with me. Would love to see what it looks like across your area. Have a great fall season, and I will see you next time for Weather Classroom. Take care, everyone.